Very well. So today we're going to talk about variability in our data. First of all, let's do a recall. Remember that in the statistical analysis process, it said that, hey, we start asking a question. This question can be, this is what we ran in San Jose State University, and it was a very cool project. What is the average monthly the rent in San Jose? So we pose a question, then we start asking the question, so collect the data, and after collecting the data, we are interested in analyzing the data by visualizing this first, how to graph the data, and then analyze the data numerically. It means that we are interested in finding the mean, the center, mode, median, and also the variability. So when it comes to center, remember that we dealt with three different types of center in the collection. We either worked with the mean or median or the mode, all right? We said that, hey, we are interested in using median for skewed data. If we have a bell-shaped, nice data, then we are interested in using mean to represent the center. For variability, we have different methods analyzing the variability in the data. When it comes to variability in the collection, we either find the range which only takes the maximum and minimum value in your collection. The range is defined as the maximum number in your collection minus the minimum number in your collection. So for example, after collecting the data about the monthly rent in San Jose State, you have the smallest amount of rent and the largest amount of rent in San Jose State. You do the subtraction between those two and you find the range in the data. Well, as a statistician, we are interested in involving the rest of the numbers as well. So suppose you have like 50 data in your collection. 50. If you just take maximum and minimum and then find the difference, you get a range, am I right? The difference between the maximum and minimum. It doesn't give you any information about the rest of the monthly rent that people are paying in San Jose State. So what about those numbers? In that case, we're going to introduce the standard deviation and variance. So the second measure of variability is standard deviation. The standard deviation, it takes on the rest of the numbers in your collection and it finds the deviation between each value in your collection and the mean of the data. Very good. So our focus today is talking about, we have a range before when we introduce the table, frequency table. Our main focus is on standard deviation, and eventually we're going to talk about 5-number summary as well. So let us begin by talking about variability in the data. Definition of range. The range is a measure of variability and it's defined this way. As we mentioned before, range is the maximum value in your collection minus the minimum value in your collection. It's a very simple formula. Just note that when you're dealing with range, we are not very interested in using range to measure variability. Range does not take into account the middle numbers. It's not a bit interesting or useful measure of variability in the collection. So I expect you to ask, well, what then? Standard deviation. So before defining the standard deviation, I'm going to show you how a calculator, how Excel, how any software calculate the standard deviation for us. Suppose I ask you to find the standard deviation of a collection of data. So what are you going to do? You're going to list each value X. Then what are you going to do? You're going to find the mean. If you're working with your sample, the mean is going to be X bar. If you're working with the population, the mean is going to be C. Mu. So this is mu. To find standard deviation, instead of working with mu, you're going to focus on your X bar. Okay. Well, after finding X bar, you're going to find the deviation between each value and the mean. Find X minus X bar. What do we call this? The deviation from the mean. The deviation from the mean. Okay, so after finding the deviation from the mean, you're going to take this number for each value in your collection and square it. X minus X bar squared. Okay, after doing that, you're going to, well, add all deviations squared together. Okay. After doing that, adding them all together, you're going to get a number. After having that number divided by n minus 1 if you have a sample. This I denoted by sigma x minus x bar squared, then divided by n minus 1. N is the sample size. This guy is called your variance. Okay. Variance is the sum x minus x bar squared divided by n minus 1. Very well. What is standard deviation? Standard deviation is the square root of variance. Standard deviation is square root of variance. Guys, again, on the exam, on the homework, on the quiz, I do not expect you to write these down. I expect you to know how to use your calculator. This is the method that a calculator uses to compute. Calculator, your software, use to find the variance and the standard deviation. Again, on the exam, on the quiz, we're not going to follow these methods to find the standard deviation and the variance. Just make sure that you know these are all written for the calculator steps. Since it's an elementary calculus class, you need to know how a calculator or a software computes the standard deviation for you. Perfect. Let's go over a couple of examples and try to feel comfortable about the concept that we're going to learn calculating, computing our standard deviation and variance. So the example that we're going to work with is related to example on page 1, chapter 2, 2.4, measure of variation. So here you have two corporations, and you have the starting salaries for each of them written in thousands of dollars. We want to know what is the difference between these two corporations. Which one should we select if we get offer from both of these corporations? So this is the question that we have. So the very first question that you should be asking is, well, what is the center? Then you need to ask the question about what is the variability? And based on these two key information, you're going to make decision which one to accept if you get the offer. These two numerical values are going to make a decision to accept or reject the offer. So let us connect to our document camera so we can write this down. Okay, perfect. Okay, here we go. So I'm sharing the Google, I'm sharing the document camera with you, and I'm going to use my calculator and write the information down so everyone can see this. Let me just move it a little bit on. This is visible to everybody. Just making sure it's not reflecting anything on your end. Okay. Not here. Here maybe. Okay. Cool. Very good. So let's see what information are given to us here. So for the first corporation, corporation A, what are the numbers that we have? What are the values that we are having? The salaries that are given to us are 41. We have, let's see, 38. We have 39. We have 45. We have 47. We have 41, 44, another 41, then we have 37 and 42. So this is for the first corporation. You want to know what is the mean, what is the center, and what is variability. Okay, perfect. Okay, what is the center that we have here already? What is your calculation for the center? How do we enter this information into our calculator? Remember that to enter this information into your calculator, first of all, turn on your calculator. If you need to reset your calculator, go to second, plus, go to reset, all run, and then second plus, reset, and this is the default as well. Very good. So first, enter this information into your calculator. How are we going to do that? We're going to go to following steps. We're going to go to Stat. We're going to go to Edit. And we're going to enter these numbers into either L1 or L2 or L3, whichever you feel comfortable working with, it doesn't matter. Enter numbers. Okay, the very first number is 41, enter, then we have 38, enter, 39, 45, then 47, then 41, then 44, another 41, a 37, and a 42. Very good. Perfect. So I entered this information into my calculator. Now to find the mean and variability, I'm going to start, then I'm going to calc. So now start, then calc. Then you're going to select one variable statistics. One variable stats. And make sure it is in L1. All the computations are from L1. If you use a different columns, second 2, L2, second 3, L3, second 4, L4, it computes all the information for you in that specific column. Since we entered all the numbers in L1, we're going to leave it as L1. So go to calculate. Well, see, we have all these information written for us here. Okay. X bar is the mean. So we found the center, which is 41.5. Then let's take a look at these two information. S sub x is the sample standard deviation. Sigma sub x is the population standard deviation. That's the difference between these two. S sub x and sigma sub x. If you have a sample, you're going to use 3.136. 3.136. So S sub x, 3.136. And if you're working with a population, the number that we're going to use is sigma sub x. Sigma sub x, which is 2.975. So that's the difference between these two, using a sample or a population and finding the variability. So again, if you're working with sample, remember keywords for samples, surveys, random samples, the mean is denoted by x bar, and the standard deviation is denoted by s or s sub x. If you're dealing with population, remember the keyword for population was every, any. The mean of the population is denoted by Greek letter mu, and the standard deviation for population is denoted by sigma or sigma sub x. So sigma, the way that you pronounce this is sigma. And this is the Greek letter mu. Mu. So if you are calculating the population standard deviation, you're going to use sigma sub x in your calculator. If you're working with a sample, the variability or standard deviation for the sample is denoted by s sub x. Okay. So let us take a look at the second corporation. We want to know what is the center and what is the variability in the second corporation. So this is a question. So let us erase what we have here for the first corporation. Corporation B. Then we're going to compare these two. So these are the information that we calculated for corporation A. Now we're going to enter information about the second corporation. The salaries listed for the second corporation are 40. So this is B. We have 40, you have 23, we have 41, we have 50, we have 49, we have 32, we have 41, and we have 29, we have 52. Let's see what else do we have. And we have 58. Okay, let us use our calculator. This is our calculator. Now I'm going to enter information in the second column. Okay. Very good. Let us go to Stat, Edit, to enter the numbers. So Edit, enter the numbers. I'm going to use the second column, L sub 2. Okay, L sub 2, well, the very first number is 40. The second number, 23, second salary. Then you have 41, then you have 50, then you have 49, then you have 32, then you have 41, you have 29, 52, 58, 58, okay, enter. So Stat, Edit, enter the numbers. This time we selected L2 instead of L1. We're going to keep L1 as it is. Now, we want to know what is the center and variability of the second corporation. We go to Stat, we go to Calc, and one variable statistic, enter. Now, guys, it is L1. You have to change L1 into L2. What are we going to do? We're going to click on second 2. Second 2 gives us L2. Very good. Now let's go to Calc. Calculation gives us the following information. So I'm going to erase this part, and I'm going to write the information for the second corporation salary here for you. The center is 41.5. Okay, it seems like they have the same mean starting salary, 41.5. And then I'm going to take a look at the variability. Again, if you are thinking about this as a sample, you have to use 11.068. If you are working with a population, sigma sub x is going to be 10.5. Okay. variability. Remember that we read this example. The example says every, each. So it means that officially you are working with sigma. You have two populations and you're comparing two populations variability. So let me write it here for you since we have the key word each, we have two populations. So the question is, which one is more varied? Which one has more variability? Okay, everybody, now let me calculate these two data. What's the meaning of them? What's the meaning of variability here? So the very first corporation says, okay, the mean that I offer, the mean salary that I offer is, the mean salary that I offer to you is 41.5, which is the mean. Suppose it's a normal distribution, it's 41.5. So in statistics, you say that, okay, if the population is normal, then we can divide up the normal distribution this way. You say that, hey, we have one standard deviation above the mean, two standard deviations above the mean, three standard deviations above the mean. So it means that here you have 41.5 plus, if you round this as 3, you're going to have 44.5. So one standard deviation. Two standard deviations above the mean, 2 sigma. You're going to add 3. Again, remember, I just round this for easier calculation. You're going to get 47.5. And 3 standard deviations above the mean, we're going to add 3, we're going to get 50.5. So this is the distribution of the salaries above the mean. So this is the center, this is the balancing point for you. 1 standard deviation above the mean, 2 standard deviations above the mean, 3 standard deviations above the mean. We're going to construct the empirical rule here. And here, 1 standard deviations below the mean. So 2 standard deviations below the mean and 3 standard deviations below the mean. So on the left-hand side, 1 standard deviation less 2 standard deviations less 3 standard deviations less. Okay. And the same for the second corporation. Just take a look at this. If you're optimistic, you're going to say that, hey, the mean salary they're going to offer is 41.5. I might end up earning 44.5 or 47.5 or 50.5 or any numbers in the middle. The second corporation say, hey, well, yes, the mean is going to be the same. The average or typical salary that we are offering is 41.5. Okay, this is the balancing point for the second corporation, 41.5. 1 standard deviation above, 1 sigma, 2 standard deviations above, and 3 standard deviations above. Then it says, okay, suppose we round this up to 11. So it's going to be 1 standard deviation above. You're going to get 52.5. Wow, take a look at this. The difference between the mean and the 1 standard deviation above. mean and one standard deviation above. Again, 11,000, it gives you 63.5, and 3 standard deviations above 74.5. So you might end up in any of these ranges here, from 41.5 to 74.5. But think about it this way. Now, what if you are not that qualified? You don't have the experience. You might end up to the left-hand side of your graph, all right? So here we have, for example, 41.5 minus 3, all right? It's going to be 38.5. 38.5 minus 3, 2 standard deviations below, you get 35.5. Well, 3 standard deviations below that, 32.5. So in the worst case scenario, you're going to get $32.5 thousand as your salary. But take a look at the second corporation. The mean is, well, 41.5 minus the variability, 1 standard deviation, 11. What do you get? It ends up in, it's 30.5, am I right? Well, minus 11, another 11, 1 standard deviation. Now 2 standard deviations. It's going to be around 19.5. And eventually, here, if you do the subtraction for the 3 standard deviations below the mean, you're going to have 8.5. So if you're not qualified, if you don't have the experience, you might end up here to the left with salary $8.5 thousand. So this is the empirical rule. This is just the beginning for a normal distribution. Empirical. We're going to talk about this when we are talking about z-values and the measure of position. Now we're going to talk about 5 number summary. Number summary, analyze. Number. You might have a skewed data, especially if you have skewed data set. What do I mean by skewed data set? Well, remember that the graph of the data are either skewed to the left or to the right. It means that you have outliers somewhere. This is your data skewed to the left. The tail is on the left.
Professor, we cannot hear you well.
So 5 number summary, if you have skewed data set, like if the tail is on the left-hand side, it means that we have outliers on the left-hand side, and we call this skewed to the left. Skewed to the left, because the tail is on the left. Or if you have data that are skewed to the right-hand side. Skewed to the right, it means that the tail is on the right-hand side, the outliers are on the right-hand side. This is our tail. skewed to the right. Skewed to the right. Then we are interested in using the median as the center or balancing point of the data. Then we are interested in using the median as the balancing point or the center. Recall what was the definition of median? Recall. Median was the middle number after ordering. After ordering the data, the middle number is called the median. Okay. So now that we have skewed data, what are we going to do? Well, the data might not be even skewed. You might be interested in finding the 5-number summary. This is what is going to happen. Suppose you have this data collection. You have A, B, C, D, E, F, G, H, I, and J. So this is the data collection that I have. Well, first find your median. What is the median of this collection here? So the median is going to be the middle number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have even numbers. It means that I have to take the average of the middle numbers, and that guy is going to be my median. So the median is going to be E plus F divided by 2. I'm going to represent this by Q sub 2, or call it second quartile. So represented by Q sub 2 and call it the second quartile. Okay, just notice that by doing that, this quartile, the middle number, divided your data into 2 sets, 2 collections. The first collection on the left, the second collection on the right. I have 2 sets. The first set here and the second set on the right hand side. Now you're going to find the median of the first collection and the median of the second collection. It's easy. Between these numbers, the median, the middle number is going to be C. And you're going to call this Q sub 1 and call it the first quartile. So this is my Q sub 1, which is called the first quartile. Okay, you know you have the second set here on the right hand side. On the right hand side of the median for the second quartile, you have a second set. This guy also has a median. Well, take that and call it the third quartile. The third quartile. Q sub 3 for the third quartile. Okay, now what is this 5-number summary that you're talking about? The 5-number summary are the minimum, maximum, and the quartiles that you find for your data collection. 5 number summary, the minimum, the first quartile, the second quartile, which is your median, the third quartile, and the maximum in your collection. Very good. This is 5 number summary. How do I use my calculator? You're going to first enter the data in your calculator. To use your calculator, first go to Stat, then go to Edit, enter the numbers in L1, L2, or L3, or any column that you like, then go to Stat, then go to Calc, then one variable statistic. Make sure you enter that in the correct column, either L1 or L2 or L3, and it match with the column in Stat Calc one variable statistic, whatever it is, just make sure it is correct. And then do the calculation. It gives you all of these numbers. Instead of Q2, you're going to see you have the median, mid or median. To visualize these numbers, 5 number summary, we're going to use Whisker's plot. Box plot or box Whisker's plot or Whisker's plot. So how does it work? Well, you have the minimum number and you have your maximum number on a horizontal line. Then your Q1, Q2, and Q3 forming some vertical lines dividing this horizontal line based on the shape of the data. If they're skewed, if they are not skewed, this box is going to be shift to the left, shift to the right, be a little bit smaller or larger. And this is going to be Q1, Q3, and then suppose your Q2 is just right here. Box plot, box Whisker's plot, or just the box plot that we have here, representing 5 number summary. I'll show you how to use your calculator to grab a box Whisker's plot. So let us use our calculator and the corporation A to find 5 number summary and graph it. So corporation A, we entered corporation A information in L1 as you saw before. So now what I'm going to do, I'm going to find 5 number summary. What I'm going to do, I'm going to use my calculator. I'm going to go to Stat, my calculator, go to Stat, go to Calc, there we go. Yes, Calc is just right here. And then one variable statistic. One variable stat. Okay. Since I entered everything in L1 for A, I'm going to switch to L1 by clicking on second one. So second one gives me L1. Okay. Now let us go to Calc. As you can see, X bar, the mean is $41.5 thousand, and these are the variabilities. N is 10, the number of values in your collection. Well, let's take a look at these. Guys, I have my minimum, which is $37,000. Minimum, $37,000. Q1, first quartile, which is $39,000. I have median or Q2, which is $41,000. And then I have Q3, the third quartile, which is $44,000. And the maximum is 47. Now for the graph. Now let's graph this together. To graph, you're going to click on second, y equals to. So second, y equals to. You're going to have different plots. I'm going to select plot 1, so enter. Make sure it's on, then go to type. You have different types of graphs here. Here you have, for example, a histogram. Here you have 2 box plots. This guy shows the outliers as well. So I'm going to select the box plot. So plot, and then turn it on and use the box plot. So just a plot like this. Box plot, okay. And then make sure you're using the correct column, L1, and then click on zoom 9. So zoom 9. This is your box plot. So the box plot is just right here. Very good. So when you're talking about 5-number summary and talking about the quartiles, we say that, hey, 25% of the data are in between the minimum and the first quartile. 25% of the data are located between the first quartile and the second quartile. You're going to say, hey, 25% of the data are within the median and the third quartile, and 25% of the data are in between the third quartile and the maximum. Very good. So now, other than quartiles, we can talk about percentiles as well. What percent of the data are above and below a specific value, or what value represents, for example, the 5th percentile, the lowest 5th percentile, the top 5th percentile, and so on. So if you have a collection of the data, the formula to calculate the percentile is as follows. Percentile formula. So the percentile of a value like X is equal to, what are you going to do? You're going to list the data in order. Make sure the data are written in order. So what are you going to do? On the numerator, you're going to count all the numbers before X. Count how many numbers are before X, and divide it by, well, the number of values in your collection. The number of values in the collection. It gives you the percentile of a specific value like X. Let's go over one example. So we are on the node 2.5. Suppose the data collection is given to you in $1,000 for the tuition costs. Suppose the data tuition costs are written here in order. $19,000 the tuition, $22,000 the tuition, $23,000, $26,000, and so on. Question says, find the percentile that corresponds to $30,000. Corresponds to $30,000. Remember that your data, we're lucky, the data is already written in order for us. So, to find the percentile for this tuition, example, the tuition. We want to know the percentile corresponds to $30,000 tuition. We're going to follow the formula. The percentile corresponds to the specific X value is equal to the percentile of $30,000 tuition is equal to, well, we need to go back to the data collection and count how many tuitions are below $30,000, not included. So you are not including $30,000, specifically before $30,000. So let us take a look at the data that we have. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 9 goes on the numerator. 9 goes on the numerator. I have 9 divided by how many numbers I have there in my collection. How many numbers are there? Well, in total I have 2, 4, 6, 8, 10. I have 12, 14, 16, 18, 20, 22, 24, and 25. So I have 25 data in the collection. Nine divided by 25, which is equal to, if you do the calculation, it's going to be equal to 36%. Okay, so $30,000 tuition represents 36th percentile. So this is the 36th percentile. 36th percentile.